Good morning, student. So, computer organization and architecture, module IV. So, topic is what? Pipelining. So, before we go through details about the pipelining, first of all, we know what is pipelining, what is the pipelining structure, and how does it work. What are the different parameters which will decide whether a pipeline is working or not, and also what is non-pipelining architecture. We will discuss all this aspect of this pipelining chapter in this lecture video. So first, why we need pipelining? Actually, each and everybody want to execute his operation more speed with accurate manner, and not only on more speed, also we want to complete the execution process with minimum time. So what we have to do, if we want to increase the execution time and better performance of a computer, then we need two things. So first one is what? So we need two things. So first one is what? Now improve the performance by introducing faster circuits. Second one is what? Arrange the hardware such that more than one operation can be performed at the same time. So if we want to increase the performance of a computer, then we have to increase the performance of a CPU. And how we can increase the performance of a CPU? Now we have two options. Number one is what? Improve the performance by introducing faster circuit. Number two is what? Now arrange the hardware such that more than one operation can be performed at the same time. So if we want to increase the performance of the CPU introducing by faster circuit, it is what? We have to install new circuits, and which is what? Quite expensive. So it is what? Expensive. So we should move for second person. In second option, what we will do there? Now we have the whatever hardware components we have to arrange them in a proper manner through which we can not only increase the performance of a CPU, we can also perform more than one operation at same time. Okay. So there is a limit on the speed of hardware, and the cost of faster circuit is quite high. We have to adopt the second option. So how the second option is possible? Now there is a concept is called what? Pipelining. By the pipelining concept, we can increase the performance and speed of a CPU. So what is pipelining? So pipelining is nothing but pipelining is a process of arrangement of hardware elements of the CPU such that its overall performance is increased. Simultaneously, execution of more than one instruction takes place in a pipeline processor. So first, what is pipelining? What is pipelining? Pipelining is a process of arrangement of hardware elements of the CPU such that its overall performance is increased. Simultaneous execution of more than one instruction take place in a pipeline processor. So how it is happening, we will discuss in next after some times. So normal you can think that suppose if one person can execute one task in 5 minutes, it is better, or one person can execute number of tasks in 5 minutes. Obviously always people will prefer the second one, who can perform multiple operations within one time. Similarly, if our computer can perform more than one task at the same times with minimum time, that is better for us. So that's why we are going for pipelining concepts. So next is what is the difference between non-pipelining or non-pipeline, or without pipelining and with pipelining. Okay, so first we should discuss about without pipelining. So in without pipelining, what happen? Assume that this is a one instruction, this is a one instruction, and this is a one instruction, and this is a another instruction. So there is how many instruction is there? Third instruction, 3 instruction is there. Ith instruction, I plus 1 instruction, I plus 2 instructions. So in non-pipelining architecture, what happen? Now each instruction will be executed complete of the last instruction. So first this ith instruction will be executed, after that the I1th execution will be complete, after that the I plus 2 instruction will be executed. Assume if so in I instruction or first instruction, how many stages are there? The 5 stages are there. Stage number 1, we will discuss about what is IF, what is ID, what is OF, what is OE, what is OS. We will discuss in later in this video. So first just think that these are the phases. These are the phases. So in I instruction there is how many phases are there? Now 5 phases are there. Okay, so if each phase take 1 minute, if phase take 1 minute, then to complete the ith instruction, how many minutes we required? Now 5 minutes. How many minutes we required? Now 5 minutes. So after finishing of this first instruction, we can proceed for the second instructions. Okay, so similarly second instruction, we already I told you that each phase required how many minutes? Now 1 minute. So second instruction also take how many minutes to complete this task? 5 minutes. Similarly, after completion of the first instruction, again second instruction we will go for the third instruction. So it will also take how many times? It also take also 5 minutes. So it also take what? 5 minutes. Okay, so total how many minutes we require to complete the task? Total how many minutes we require to complete this task? 5 plus 5 plus 5, 15 minutes. So number of and you can say how many number of phases are there? 1 2 3 4 5 6 7 8 9 10. So total is what? 15 phases. So 15 phases. So number of phase duration is what? 15. So number of time required to complete this phases is what? 5 into how many instruction is there? 3 instructions. So 15 minutes is required to complete the total execution of the instruction, or total 3 execution or executing the 3 instructions. So how many time we require? Not 15 minutes. So if 15 minutes we require to execute the instruction. So this concept is called what? Non-pipelining concept, or you can say instruction wise interlink. Instruction wise interlink means what? Now first instruction will complete, after that second instruction will complete, after that third instruction will, like this it will continue. That's why it is called what? Instruction wise interlink. Means until the first instruction complete his operation, second instruction cannot be executed. Until the second instruction complete his task, we can't execute the third instruction. So that's why it is called what? Instruction wise interlink. So how many phases is there? Now 15 phases is there. And how many times we required? Now if one instruction required 5 minutes, then 3 instruction will require 15 minutes. So TP, this is what TP, this is called what? I told you, this is called what? Phase, or you can say 1 clock cycle. Okay, so one TP is what? Phase duration, and TN is what? The execution duration of each instructions. Get it? So this is what? Non-pipelining. So in non-pipelining or without pipelining, if we want to execute 3 instructions, then it required if we want to execute 3 instructions and each instruction having 5 phases, then it required how many minutes? Not 15 minutes. How many minutes? 15 minutes. So let next come to the with pipelining. So what happened with pipelining? Come here. Now with pipelining, look how many instructions is there. Similarly in pipelining 3 instructions there, in with non-pipelining 3 instructions there, and in pipelining also 3 instructions is there. So in first instruction, how many phases are there? 5 phases are there. In second instruction, how many phases are there? 5 phases are there. In third instruction, how many phases are there? 5 phases are there. So total how many phases are there? 15 phases are there. How many phases are there? 15 phases are there. This is what? one cycle. This is called what? One cycle. 1 clock cycles. So how many clock cycle or number of phases duration is what? 15. So how many time it will take? So I told you, if one phase take 1 minute, so this first instruction will take how many minutes to complete? 5 minutes. Obviously 5 phases are there, so it will take how many minutes? 5 minutes. So look what happened in with pipelining. So when stage 1 is insert in fast, when it will move to second stage, in second instruction the first phase will started. Look here when the first instruction stage 1 move to stage 2, at the same time the first instruction is starting the execution. The first the first stage of second instruction is started is executions. Similarly, when the first instruction executing his third stage, second instruction is executing his second stage. At that time, third instruction is executing his first stage. Are you understand? Are you getting my points? Look, again I am telling. In first instruction, how many phases are there? 5 phases are there. When, or you can say 5 stages are there. So when the first stage is executing, there is no another stage is present, or no phases are there in pipelining process. When the first stage of first instruction complete his task, he will move to second stage. At that same time, your first, this space is free. You know, this space is free. So easily we can insert a second instruction first stage. Similarly, when the second stage complete his task, he will move in first instruction, he will move to third stage. At that same time, the first instruction moves to the second instruction will move to into second stage. And in case of third instruction, what happened? Now when first instruction executing his third stage, second instruction is executing his second stage. At that time, third instruction will execute his first stage. Okay, so if it will take 5 minutes to complete, So after 1 minute the second instruction started its execution. So it will take how many minutes? 5 plus 1 means it will 5 plus 1, this is what, 1 minute extra. It will take what? 6. So in 6 minutes we will execute 2 instructions. Okay, again come to the third instruction. So when second instruction is complete his task, after 1 minute the third instruction will complete his task. So it will take his what, how many minutes? 7 minutes. So first execution will be completed in 5 minutes, second execution will complete after 1 minute of the first instruction, again third instruction is completed after 1 minute of the second instruction. So it total take how many minutes to complete the task? 7 minutes. How many minutes? 7 minutes. How many minutes? 7 minutes. Well, pipelining is taking how many minutes? 5 minutes. Pipelining is taking how many minutes? 7 minutes. So let take a real life example, then you can understand this concept more clearly. So before that, okay, just I'm giving you the real world example, which will be help you to understand more clearly about the pipelining concept. Okay, just wait. Suppose so already we discussed what pipelining is a process of arrangement of hardware elements of the CPU so that its overall performance is increased. Simultaneously execution of more than one instruction takes place in a pipeline processor. So let us see a real life example that works on the concept of pipeline operations. So consider a water bottle packaging plant. Let there be 3 stages. Consider there is a water bottle packaging plant. Consider there is a water bottle plant. Okay. So let there be how many stages? 3 stages that a bottle should pass through. So first stage is what? Inserting the bottle. First stage is what? Inserting the bottle. So take it what? Stage 1. What? Stage 1. So after inserting the bottle, what we have to do? Now fill the bottle. Fill the water bottle. What? Now fill the water bottle. So this is what? Filling the water bottle. Stage 2. So after filling, we should go for the cell. Assume that there is what? Next stage is what? Stage 3 is what? S3, that is what? Cell. Selling the water bottle. So consider a water bottle packaging plant. Let there are 3 stages that a bottle should pass through. Inserting the bottle, filling water in the bottle, selling the bottle. Okay. Let us consider these stages are stage 1, stage 2, stage 3 respectively. Okay. So let each stage takes 1 minute to complete its one operation. So each stage take 1 minute to complete its one operation. Stage 1 will take 1 minute, stage 2 will take 1 minute, stage 3 will be take 1 minute. So total how many minutes it required to complete this 3 operation? Obviously 3 minutes is there. So let will draw a diagram. So okay, let will draw diagrams, then you can easily understand what I am trying to say. Okay. So how many stages is there? 3 stages is there. Okay. Suppose 3 stages are there, and we want to perform what? We want to produce 3 water bottles. So how many time it will take? Let's calculate. So for first water bottle, first we have to do what? Inserting the bottle, and second, after first stage we have to go for what? Filling the bottle. Then next stage is what? Selling the water bottle. Okay. So after that we can complete our task. So if we want to sell a water bottle, then we have to process through 3 stages: inserting the water bottle, filling the water bottle, and sell the water bottle. So it will take how many minutes? Obviously 3 minutes. Okay. Similarly, this is for what? Fast water bottle. This is for what? Fast water bottle. This is for what? Fast water bottle. Again, second water bottle. Suppose we want to fill second water bottle. So again it will take how many time? 3 minutes. Obviously it will take how many time? 3 minutes. So after finishing this 3 steps, again we will go for the 3 steps. Yes or no? A1, 2, and this is what? 3. This is what? 3 steps. So inserting, filling, selling. Yes or no? So again this is what? Second water bottle. This is first water bottle. This is second water bottle. Again, if you want to produce another water bottle, again we have to go for 3 steps. So first, in second, third. Okay, first, third. So draw the diagram properly, easy to understand. Okay. So it will take how many minutes? 3 minutes. Again it will take how many minutes? 3 minutes. So without pipelining, it required how many times? Now 3 plus 3 plus 3, 9 minutes. What? 9 minutes required. How many minutes required? Now if we want to produce 3 bottles, then it will take how many minutes? 9 minutes. So average time to produce one water bottle is what? 9 by 3, that is what? 3 minutes. Yes or no? So we need how many minutes to produce one bottle? Not 3 minutes. This is by the help of without pipelining. Okay. So come to, but in pipeline what happened in pipeline operation? Now when the bottles in pipeline bottle, what happened? Let's draw the diagram. Stage 1, 2, 3, 5. Okay, look, how many bottles? 3 bottles, na? 3 bottles we want to produce. What? How many bottles? 3 bottles. We want to produce how many bottles? 3 bottles. How many bottles? 3 bottles. So suppose when the when this is what? First inserting the bottle. Okay. Second operation is what? Filling the water bottle. Next is what? For sell the water bottle. Okay. So in pipelining what happened? Now when this is what? Stage 1. So after complete of stage 1, it will go for what? Second stage. At that, when we move the second stage, stage 1 is free. Yes or no? Stage 1 is free. Yes or no? Stage 1 is free. So at that time, why will free the CPU? Why not we will engaging the CPU? Yes, we can engage the CPU. How we can engage? Now we will go for the second water bottle. We will go for the second water bottle. What? We will go for the second water bottle inserting. Okay. So when water bottle is when the first water bottle is complete his second stage, he will move for third stage. At the same time, second stage is free. We can enter it to here. What? Second stage. Okay. So when after complete the third stage, water bottle will go for sell. So at that same time, our filling will be continuing. Then we will go for the selling part. Yes or no? At the same time, look here. When when the bottle move so now in pipeline operation, a bottle is first inserted in the plant. Okay. After 1 minute, I already told you that it will take, we require 1 minute to complete one task. Okay. So a bottle is first inserted in the plant. After 1 minute, it is moved to stage 2. where water is filled. Now in stage 1 is nothing, happened. Similarly, when the bottle is stage 1 is nothing, after 1 minute we will move to stage. Now in stage 1 nothing is happening. Similarly, when the bottle move to third stage, both stage 1 and stage 2 is free. Yes or no? So listen carefully, again I am telling you. Now what happened in pipelining? A bottle is first inserted in the plant. Okay. After 1 minute it is moved to stage 2 where water is filled. Now stage 1 is what? Free. Yes or no? This stage is free. After inserting this one, he will come to second stage. Obviously stage 1 is free. Okay. Similarly, when the bottle moves to stage 3, both stage 1 and stage 2 will be free. Yes or no? Or you can say both stage 1 and stage 2 will be ideal state. But in look here, in this case, when stage 1 second stage it will free, when stage move to stage 3, so these two space are ideal in stage. But in pipeline what happened, when the bottle is in stage 2, another bottle can be loaded at stage 1. Similarly, when the bottle is in stage 3, there can be one bottle in stage 1, another bottle will be in stage 1, another bottle will be in stage 2. So after each minute we will get a new bottle at the end of the stage. So first stage, second stage, third stage, first stage. So when second bottle is in first, when the second bottle moves to second stage, so third bottle will be inserted. Again the second bottle will move to third stage. The third bottle can proceed for his second stage. When it will complete the third stage, sorry. This is what? This is in first stage, and this is what? Second, and this is what? First stage. So when it is in first stage, so it will complete. After complete first stage, he will move for second stage. When second stage work is finished, at the same time we can insert another bottles into first stage. When it will move to its third stage, at the same time second bottle is moved to second stage and new bottle is inserted into first stage. Okay. When it will complete his task within 3 minutes, after 1 minute he will complete, second bottle will complete his task. Again after complete the second bottle, after 1 minute the third bottle will complete his task. So total how many minutes they requires? Now 1 plus 1 plus 1 plus 1 plus 1 plus 1. This is what? Total 5 minutes. Total what? 5 minutes. So with pipelining, it required what? 3 total time. First instruction will be executed in 3 minutes. Second will be what? After 1 minute it will produce, and third will be after 1 minute it will produce. So total it will take what? 5 minutes. How many minutes? 5 minutes. So average speed will be what? Now 5 by 3 minutes equal to what? 1.67 minutes. So without pipelining it will take what? 9 minutes to complete one bottle task. It will on an average is what? 3 minutes. But with pipelining, if we want to produce 3 water bottle, it will take how many minutes? 5 minutes, and average speed is what? 1.67 minutes. So tell me which will be the better? Obviously pipelining concept is better. By using pipelining concept or by the arrangement of the hardware devices in CPU, we can speed up the execution process of a process. Of a process. So when we want to execute 3 instruction, it will take 9 minutes in non-pipelining, where in pipelining it is taking how many minutes? 5 minutes. Get it everybody? So this is the difference between non-pipelining and pipelining. So non-pipelining taking more time, while pipelining is taking less time. Non-pipelining is taking more time, pipelining is taking less time. Get it, everybody? Okay. So next we will proceed for the concept. Already I told you what non-pipelining. There is 3 instruction in non-pipelining. If there is 5 stages, then it will take what 15 minutes. But in pipelining, it will take how many minutes? 7 minutes. Okay. So what is a pipelining? Now, pipelining is a process of arrangement of hardware elements of the CPU so that its overall performance is increased. Get it, everybody? So next we'll go for the design of pipelining. We'll go for the design of pipelining. So in pipelining, design of pipelining. So in pipeline process, a pipeline has 2 ends. One is input ends and another one is output ends. Between the input ends and output ends, there are multiple stages. Or segment. These are the stages. Multiple stages will be there. Stage 1, stage 2, stage 3, and stage ends. These are called what? Stages. These are called what? Stages or segment. What? Stages. These are called what? Stages or segments. What? Segments. So between the input units and output units, there will be number of stages will be there. Okay. So that output of one stage is connected into input of the second stage or input of the next stage. Each stage perform a specific operation. Stage 1 will be perform one operation, stage will be perform another operation, stage 3 will be perform another operation. Like that, stage n will be perform another operation. So between the stage 1, stage 2 and number of stages, there will be a interface registers are used to. This is, you are looking this figure. This is nothing but it is a what? An interface register which are used to hold the intermediate output between 2 stages. Suppose stage 1 is continuing finishing of task. He will store his output in this interface registers. So this output will be input for the second stage. Similarly, after finishing of stage 2, he will produce the output, and that output will be held in this stage interface for some while. Again, this output will be become the input for the stage 3. Okay. So look, so interface register are used to hold the. So these are called what?